Okay, today we're going to talk about significant figures. Okay, in science, guys, we use a lot of numbers. And we have to make sure that when we use these numbers, we use them in the proper manner and figure out which ones count and which ones don't. Because here's the weird thing. Sometimes when you're doing numbers and you're using numbers, some numbers are actually valuable and some aren't, especially when we look at numbers when we're writing them out. And when a number is valuable, we call it significant. It actually does matter when we're dealing with the numbers itself, okay? So there's some rules that come applying to significant figures. Okay? Well, first off, a number that is a non-zero, so we're talking about 1 through 9, okay? Those numbers, any number that you write out, those numbers are going to be significant, okay? They're going to be counted. They're going to be a valued number, okay? So a 1 through 9 is significant. So if I look at this one like 3,456, how many significant figures does it have? How many of its numbers in that number itself are valuable or significant, okay? Well, that would be all four of them. The 3, 4, and the 5, and the 6 are all valuable. They're all significant because they are actually measuring something, okay? They have a measurement that has a value to it. So all the non-zero integers, when we come to significant figures, they count. They are useful. They are valuable. They are significant, okay? Now, that leaves us with the only other number left, which would obviously be a 0, right? Now, zeros are a different breed here altogether because they sometimes count and sometimes they don't count, okay? When do they count and when do they don't? That's what we're going to look at right now. If you got a 0 and it's called a leading 0, okay? A leading 0 does not count. It is not significant. So if I take this number here, 0.0486, how many significant figures does it have? How many of those 5 numbers there are actually valuable? They have significance. They mean something. Well, the answer straightforward is 3 of them. The 4, the 8, and the 6 are all valuable. The 2 zeros at the front aren't. What these 2 zeros do right here is they basically help with one thing. These 2 zeros right here. What they do is they tell you where the decimal is at. That's all they do. Those 2 zeros tell you where the decimal is at. Okay? That's the only thing that they're placeholders for the decimal point. That's it. So when it comes to actually being valuable, those numbers aren't valuable as far as the math and the whole idea of that number goes. They don't mean anything. Okay? They don't represent something tangible, I guess is the better way to say it. Okay? Now, what if that 0 is in the middle of something? Called a captive 0. Well, captive zeros do count. Okay? Now, what does that mean? Well, 16.07. How many numbers there are significant? There's 4 total, right? How many of those 4 are significant? Well, all 4 of them. Okay? Now, why does this 0 count and the others don't? Well, because what it says and what it's telling you is that these are absolutely, completely measured. I measured to exactly 16.07 grams or meters or whatever, right? I specifically measured that much. It is an exact amount of stuff, okay? I measured exactly 16.07 grams or whatever I'm using to measure. In this case, we'll just say grams, right? That's what that means. So that 0 is significant because it's between these 2 numbers. That's why they call it captive. It's between 2 non-zeros, a 6 and a 7 in this particular case. So this one does count. It is valuable because it's telling you that there's something after this as well. Okay? Now, the last type of 0 is called a trailing 0. Trailing zeros do count if and only if you have a decimal point. Okay? They count if and only if you have a decimal point. So this number right here, 9.300, has 4 numbers total, but how many of them are significant? All 4 of them. Okay? All 4 of these are significant. And I'm going to show you why right now. Okay, come on. If I take 9.3, excuse me, here, let's try this. Let's go 9,300. If you look at that number, you got 2 trailing zeros. There is no decimal point. So that should be 2 sig figs, right? 2 significant figures. Now, if I do this though, if I do 9,300 decimal point, that changes things. I know that sounds weird that it changes things, but it does. That's only 4 significant figures. Now, why is that? Well, what this means is whatever I've done with this number, I have exactly measured it to exactly 9,300 exactly, right? There's no change here. It's going to be exactly 9,300, okay? This one right here, 9,300, there's no decimal. This is kind of an estimate. We're not exactly sure what it could be. It could be 9,300 exactly. It could technically be 9,300.0001, right? Or it could be 9,300.09 or whatever. That last thing, this is an estimate. It actually could be 9,299 for all we know. It's an estimated number. So this is not nearly as accurate as this, putting that decimal point there. We measured somewhere. It's just like if you look at somebody and estimate how much they weigh, and then you put them on the scale and they weigh a little bit more, a little bit less than what you estimated. You just estimated. You know, if we took today and we estimated our weight and we said, I'm 225 pounds, right? But you got on a scale and the scale said you weighed 225.8 pounds. Well, you were estimating, you got close, but it wasn't as significant as the actual specific number. Okay? So that's the difference between the 3 kinds of zeros. Okay? Now, what we want to do next, real quick, is I want to go to this here. Okay. Oh, here. Ah, got it. There we go. On the button. All right. I want to look at some practice ones for just about 2 minutes here. Okay. If I have 1.0070 meters, how many sig figs do I have? Okay. Well, if I look at it, that means I've got 1, 2, 3, 4, 5 numbers total. I have a decimal. That decimal will tell me really quickly that this trailing zero here counts. These captive zeros already count, so that means I have to have 5 significant figures. Okay? If I take this one, and again, 17.10 kilograms, there's another decimal again, that trailing zero counts. So I have 4 sig figs, those. If I look at this number, 100,890 liters, how many significant figures? Well, I've got 6 total. These 2 are captive between the 1 and 8, so they count. So that gives us 3, 5 of them. That zero is trailing. It only counts if there is a decimal. There is no decimal. 5 significant figures. So this is a rounded up or down number. It's an estimated number. 3.29 times 10 to the 3rd seconds. Well, I got 3 right here. I don't care about this right here at all. That doesn't count when I'm talking about sig figs. So I got 3. Okay? Which we'll talk about those later. 0.0054 centimeters. These 3 zeros are nothing but placeholders. So it's only those 2 sig figs right there. Okay? And then finally, 3,200,000. I've got 7 numbers right there. Those 7 numbers, 5 of them are zeros, the other 2 are non-zeros, right? So these 2 count. These are trailing zeros. There is no decimal, so they don't count. So there's only 2 sig figs. Now again, this was a quick rundown of significant figures. I hope it helps you a little bit. If you get stuck, go back to it. You got my email. Ask me anytime you need anything, okay? All right.